in 5, 4, 3, 2, 1. Chapter 7. Now we're actually going to start talking about reactions. So far, all we've done is, balance them and talk about their math. Now let's talk about their varieties. Talk a bit about what they're used for, what they do. We're going to go into all of these in more detail in later sections. So we have precipitation reactions, or double displacement reactions. So precipitation is when a dissolved substance falls out of solution. Okay? So rain or snow, those are both forms of precipitation. Water dissolved in the air, coming out of the air as precipitation. We usually, though, talk about solids. So in this case, down here at the bottom, we have potassium iodide reacting with lead 2 nitrate. Typically, these two salts will swap their partners. Okay, so these guys are both dissolved in water. They're both nicely soluble in water, okay? Hence the aqueous. And then they swap their partners so that the nitrates go over to the potassium and the iodides go over to the lead. So you end up with potassium nitrate and lead 2 iodide over on the right. Now, potassium nitrate is still soluble in water, but lead 2 iodide is not. Okay? So it falls out as a solid. Now, I've seen a lot of people having trouble with this. S means solid. Don't confuse it with soluble. The solid is insoluble. Okay? So a big part of learning to deal with precip reactions is learning to recognize salts that are soluble versus salts that are insoluble. Okay. Next up, we have acid-base neutralization. This is kind of like a specialized precipitation reaction. You have an acid and a base, you mix them together, you're going to get a salt and water. Usually. There are some special exceptions. But it's so it's they're still swapping partners more or less. So you have sodium hydroxide and HCl. The H goes with the OH, the Na goes with the Cl, so you get NaCl and H2O. HOH is H2O. Likewise, barium hydroxide plus sulfuric acid, you get barium sulfate and 2 water molecules. Not all acids and bases look exactly like this, but this is the most common class of acids and bases. Acids usually have these acidic protons, and bases usually have these hydroxides. Finally, the one you will learn to hate is redox reactions, or oxidation reduction, when two substances exchange one or more electrons. So a simple version of this is you have magnesium and hydrochloric acid. The magnesium loses 2 electrons to hydrogen, and you end up with magnesium chloride and hydrogen gas. That's the simple one, relatively easy to balance. But then you have the much more complex potassium manganate reacting with sulfuric acid and hydrogen peroxide to make magnesium 4-sulfate, potassium sulfate, oxygen, and water. All right. This is a lot harder to balance, mostly because it's weird. They take place in acid, and there's all sorts of stuff going on. And there's a special set of rules for balancing redox reactions. They're much more difficult than regular reactions when it comes to balancing them. So those are the 3 varieties of reactions we'll be talking about. Precip reactions, neutralization reactions, and redox reactions. So I will see you in a few minutes to continue talking about this when we start with electrolytes. What is